Okay, for all of you that want to learn about inequalities, these less than or equal to, greater than, and so on, you've come to the right place. So here we go. So at the very basic level, the inequality is really just a comparison. For instance, this is 2 is less than 5, which is obvious. Or you can say 5 is greater than 2. What also might be said is something like this would be said to be true. Or you can have something like this where 6 is greater than or equal to 6. That or equal to is that extra line right there. And this statement is also true. Or 7 is less than or equal to 5. That's false. So at the very basic level, it's really just a true or false comparison. Now for a problem like this, we have x is greater than 4. And the question is, well, what value could we put in for x? Well, there's an infinite supply that we could put in for x. And that's where we introduce something like a number line. And as we introduce numbers greater than 4, we identify, well, 4 is right there on the number line. And numbers greater than 4 start here. And they go in this direction. And so that is called the graph for x is greater than 4. Notice this dot right here is saying, okay, we're starting at 4, but we're not including 4. That's why it's empty and we're not coloring it in. As to a problem, something like this, where this is x is less than or equal to negative 2. And we can graph this as well. Now, over here, negative 2 is on the left-hand side, somewhere on the left-hand side over here. And if we're going to graph something like this, we need to include a closed dot. That means that we're including negative 2. And numbers less than negative 2 go in the left-hand direction. So that's the graph of x is less than or equal to negative 2. It fills in this idea that what are all the values that are smaller than or equal to negative 2? Well, they start here, and they're all on this side, as opposed to what numbers are greater than 4. Well, it starts here, but it's not 4. It's anything bigger than 4, or to the right of the number line of 4. And so for level 3, I say it's something like this, where we have x, some number plus 3, is less than negative 5. Well, what's the value of x? Well, it could be a lot of things. It could be anything that when you add 3 to it, it ends up smaller than negative 5. And the way we solve something like this is we will solve it like an equation. And you're used to something like that. At this level, we subtract 3 from both sides. And we get x is less than negative 8. And then we can graph it. We would graph it as, well, it has to be negative 8 is somewhere over here. And we would have an open dot because we're not including negative 8, but we're starting at negative 8. And then all the numbers smaller than negative 8 go to the left. And so as we're asked to solve, this would be our solution, and this would be the corresponding graph for the solution. And you might have something a little bit larger. This is solving a larger inequality problem where we would subtract 1 from both sides. And we're left with 2x is greater than or equal to 11. That second step, if you've ever solved two-step equations, would be to divide by 2. And just like the 1's cancel here, and the 2's would cancel here, and we're left with x is greater than or equal to 11 halves. Or 11 halves is the same as 5.5. And usually these problems are graphed as well. So 11 halves is 5.5. So 11 halves is somewhere to the right-hand side because it's positive of 0. And we would have a closed dot because This extra little line right there is saying that we're not only starting at 11 halves, but we're including negative halves as well. So that's closed. And the numbers greater than that go in the positive direction. This is my level 4 of 4 levels where we have a negative coefficient. That coefficient, and the coefficient is the number that is being multiplied by the variable right there. And to solve this inequality, we would do what we normally would do, and that is to divide by -3 on both sides. And those -3's cancel. We get x on that side, and 12 divided by -3 is -4. But the fact that we divided by negative, we have to switch the direction of the inequality, opening the other direction. That's the step that all students forget. And so graphing something like this would be like we have been before. This is -4. I'll do that in yellow. -4. And we're talking about numbers less than that. So we start at that point, and we have to not include -4. So we go to the left. And we have one more example, and that is something like this. Students often think that this one's the scary one. X divided by -2, simply because they see the fraction there is greater than or equal to 6. Well, what I would do is I would just multiply. I would do the inverse of it. I would multiply by -2. That gets these -2's to cancel, but you have to do that on the other side as well to keep it all balanced, just like an equation. Times -2. And what we get is x, and on the right-hand side, we get -12. But the fact that we multiplied by a negative, you have to switch the direction of that inequality going the other way. Right here, that is the step that students will miss right there. And of course, we'd have our graph, and we'd start at -12, but we would also include -12. So that's going to be a colored in dot. And since it's smaller than -12, we have to go in that direction right there. And those are all the things you need to know about absolute value, not absolute value, inequalities. The greater than or equal sign, less than, that is that's about as complicated as it gets. Of course, there are other scenarios, but when we're talking about middle school, algebra, and such, all they do is dress it up with more complicated equations. But that is the nitty-gritty that'll get you pretty far. So let me know how it goes. Let me know if you have any questions about this in the comments. And thank you for watching.